Hi, it's Mike Power of Silver Range. Here's a look at our Alamo project. First, a quick word from our lawyers. So what's the story at Alamo? Well, we've got high-grade copper and gold mineralization at surface. Our surface samples are running an average of 4 grams a ton gold and 2.5% copper. Historic mines on this property have been worked down to 1,000 feet or about 300 meters. There's been no modern exploration. And we think we can unlock some real value here by applying some modern exploration tools to find where all this high-grade surface mineralization comes together. Alamo's located in the Harkava Mountains, about 10 miles north of Wenden and about 70 kilometers east of Parker. There's a paved county road runs by the eastern side of the project, and it's a couple kilometers in on a 4x4 to almost anywhere you want to get to in the property. Currently consists of 20 federal loan claims. They're located on BLM land and there's no surface impairments. The first mineralization in this area was found by James Cunningham, after whom the Cunningham Pass is named, and that was in the 1880s. By the turn of the 20th century, there were about 25 miners working in the area on little pits and shafts and adits. Things really took off with the development of the Critic mine, which produced between 1909 and 1916. It shut down, and then the Wenden mine went into production between 1916 and 1930. Our project centered on the Wenden mine. Production at the Wenden mine began at the old number 1 shaft on the Copper Chief claim. They worked down to about the 300-foot level, and then, since they were still in mineralization, they decided in 1929 to commission the Barkdale shaft, and that worked the load down to the 1,000-foot level, and they were heading towards 1,500 feet. Reportedly, they were working mineralization up to 32 feet wide at the bottom of the Barkdale shaft. We don't know the total production on the camp. We know that it was shipping ore valued at $100 a ton, or about 4.5 ounces per ton gold equivalent in 1929. Here's a look at what's left. We're looking now at the old Barkdale shaft here, flying from north to south. You can see there's a lot of spoil. Off to the west is the old number 1 shaft on the Copper Chief claim. And if you look very carefully in the distance, you'll see some concrete pads where their miners had a small little town along that road that heads up towards the hills. Here's a map of workings, the underground workings up in the northeast corner of this map here. We've only mapped about 1/3 of the claims to date, and there are plenty of workings on the property. Turning to the regional geology, the Alamo property is located on the north flank of the Harkava Mountains. It's right here. The Harkava Mountains are underlain by high-grade metamorphic rocks, upper amphibolite to granulite facies, gneisses, and metasediments and metavolcanics. And these are intruded by Laramide age granitic rocks. The reason we see this unusual package of very highly metamorphosed rocks in this area is the fact that the Harkava Mountains are in the core of a metamorphic core complex. Now these form in areas where the crust is subject to extreme tension, pulling it apart, and at the same time, a lot of heat and mantle upflow, and this thins the crust underneath. The tension creates these normal faults, and the inwelling and uplifted lower crust causes uplift beneath the normal fault here. And this area of uplift widens, and it tends to migrate in the direction of the transport of the overlying plate. So it starts from this normal fault, and then material is continually shed away from it. And this zone of uplift starts near the normal fault and then moves away from it. Now, when the mantle upwelling that causes the heat flow under here ceases, the whole structure is frozen in place. And you end up with something that looks a little like this. So here's that initial normal fault, the breakaway fault. Material was transported away in the direction you see here. There was an uplift in the basement. And this created this culmination here. The rocks under here are what we call the lower plate. These are all high-grade metamorphic rocks, and the overlying rocks are, relatively speaking, unmetamorphosed, but they're highly fractured by all this normal faulting here. Separating the two is a detachment fault you see right here. In the metamorphic core complex, there are lots of lineations in the direction of transport, but not shown here very well are structures that are perpendicular to it. These are tensional features, and these play a very important role in localizing the mineralization on the Alamo project. So the Alamo project is in the Harkava Mountains, as I said, and you can see here this line of metamorphic core complexes extending off into California. This is the core of the metamorphic core complex when it froze. Now, material was shed from a breakaway fault somewhere here and transported off in this direction. Subsequent to that, there was additional crustal extension, but not accompanied by high heat flow, and that led to basin and range extension, which is almost perpendicular to the direction of transport you see here. That deformation was expressed as Horst and Graben, or zones of uplift and depression, as the crust was thinned, and that led to the formation of these mountain ranges you see here, and most particularly to the formation of the Harkava Mountains. Associated with metamorphic core complexes in Arizona is iron oxide copper gold, or IOCG, mineralization. Now, this is characterized by hematite, either specular hematite or this more earthy variety here, along with sulfides at depth, pyrite, chalcopyrite, galena, and you have secondary sulfides such as chalcocite, and you have oxides such as chrysocolla, malachite, azurite. This hematitic material that's almost all mineralized is injected into veins and breccias. The veins occur at all scales. I should point out all these photos, by the way, are from material on the Alamo property, and you see centimeters thick veins. You can see some nice copper in this one here. Exposed at surface on the Alamo property, they range up to about 1/2 meter. And as I pointed out earlier, there are reports of much thicker mineralization at depth in the Wenden mine. Iron oxide copper gold mineralization occurs in a variety of settings. Here's the basal detachment fault in the metamorphic core complex. These are the lower plate high-grade metamorphic rocks. These are the rocks that are shed off of it. IOCG mineralization forms along the detachment fault. It also forms in the lower plate, and it's found in the upper plate in a variety of settings. To date, 6 out of 15 deposits or camps in Arizona and extreme eastern California are developed in the lower plate rocks. There are 8 deposits in the upper plate, including a couple of large ones, notably the Copperstone mine, and there's 1 deposit that's found straddling the detachment fault in both the upper and lower plate. To date, the largest deposits have been found in the upper plate, but the lower plate deposits have more gold. Turning to the property geology, the portion of the claims that we've mapped to date, the eastern third, is underlain entirely by Proterozoic gneisses. These are high-grade, at best upper amphibolite or even higher grade feldspathic quartz gneisses. You can see them here. They have a pervasive northwest trending foliation. I've tilted the map a bit here, so this is trending northwest, and there's a northwest trend to the foliation and to parasitic folds within it. Now, in addition, there are brittle structures, and these are those perpendicular to displacement structures I mentioned in the metamorphic core complex slide. These are brittle veins that have developed perpendicular to the direction of transport in the metamorphic core complex. So they're just about everywhere. And you can see that they are, in fact, brittle features with sharp walls. And most of them are filled with iron oxide, copper, gold style mineralization. It basically injected all of the fractures that we see in this property here, in the part of the property here. At surface, they look like this. You'll see zones of black rubble. Sometimes these zones come together and in portions of the property, and it looks like there are areas where the veins may in fact be coalescing. Here's what they look like. There are wider shear zones here, nonetheless, with iron oxide copper gold in them. The widest shear zone we've seen to date on the property is about 11 meters wide. The mineralization is mostly oxidized, so there's chrysocolla, a bit of malachite and azurite, along with hematite. The direction of transport in these veins is horizontal. There's an alteration between the veins, kind of this greeny gray alteration that occurs between the veins. It doesn't extend very far around them. Individually, the veins range from centimeters to half meter or so, and as I said earlier, reported at wider widths at depth. And at surface, they tend to form these zones of rubble like this, and you can trace individual veins along by just following the hematite copper float. Here's a look at our sampling to date. Of 48 samples, our average grade is 4.5 grams, and 14 out of our 48 samples are better than 5 grams per ton. And peak values are not associated with the old mining operations up here. They're down in this part of the property here. And over here, and this is actually, there are no workings in this area whatsoever. So widespread high-grade gold and copper. Look at the values here. Basically, a third of our copper numbers are better than 2% copper. There's widespread copper. You'll note that it's a little more common as well up near the old mining operation, but there's plenty of copper down in here as well, where there hasn't been a lot of historic mining. We've run soil geochem surveys. The gold response is in the general area of the mineralization that was mined, but it's a little bit smeared. The copper's a little more focused on the historic mining areas. Nonetheless, both copper and gold seem to be pointing to areas where we might find bedrock mineralization beneath the thin soil cover. We ran a VLF survey, had an EM16 with us, identified a number of conductor axes. You're looking here at Fraser filter data, and then the conductor axes were picked after profiles. And we did this and then put the gold on it, and we're surprised to find, pleasantly I should point out, that the conductors seem to be associated with gold values at surface in most of the cases. Putting it all together, we see several targets on this property already, and we've only mapped, as I said, the eastern third of it to date. There's a nice big zone up here associated with the old Barkdal and number 1 shaft. There's this zone down here with a few historic workings that, if anything, looks better than the one to the north. And there are some other smaller targets. And we have good support in copper and also in gold. So we're off to the races. So what's next? Well, we think Alamo would really benefit from a program of modern surface exploration. We'd start with geology and sampling, of course, but then do soil geochemistry, as that's provided a means of locating these broader areas of copper gold mineralization. We'd run geophysics, both EM, and we'd like to try IP. Specular hematite is, in fact, a chargeable mineral. If we can find areas where we have geological, geochemical, and geophysical support, we think we'll be able to develop some great trenching targets. If some of these turn out to be zones where a number of these veins coalesce to form a thick zone of mineralization, we'll think we'll be really on to something, and then we try some shallow drilling. We believe that the old timers, each individually, were working these smaller veins, but the real future here lies in finding zones where they all come together to form a larger, perhaps a little lower grade, but nonetheless rich mineralized body. So that's the plan at Alamo. We were there last February. We went there in May, and we're planning on heading back this fall. We got high hopes for this property. So stay tuned.